Continuing with our discussion, it might be beneficial for us to make arc length a parameter. Because if we make arc length a parameter, some things turn out to be a little bit nicer. So how do we do that? Well, the arc length function, if C is a smooth curve given by the vector value function r of t and then defined on AB, and for t between a and b, the arc length function is given by s of t equals integral from a to t actually of the derivative of our vector valued function. I'm sorry, I should say the length of the derivative of our vector valued function evaluated between a and t, and I just put in a dummy variable u for that. So there's the length of the derivative and evaluated between a and t. This arc length s is called the arc length parameter. The arc length function gives the distance from x of a, y of a, z of a to x of t, y of t, z of t. As the blue part in this sketch shows, I'm assuming this wire here is the vector valued function, and the length from this point to this point is the length on the curve from here to here. It's the length of that blue piece of wire. So from the second fundamental theorem of calculus, the derivative of an antiderivative is the function itself. So from that we can conclude that the derivative of this arc length function, whoops, I went too far, of this arc length function is the function itself. So the length of r prime of t. Here's a quick example. If you'd like to see, would you like to see an example? Okay, so we'll look at an example. Here's an example. Find the arc length of the vector valued function, which is just a line, r of t equals x plus a of ti. Sorry, that was x sub 0 plus a of ti plus y sub 0 plus btj plus z0 plus ctk on the interval from 0 to t. And so s equals, as you can see, the derivative of this is just the number a, since that's a constant times t. The derivative of this parametric equation is just b. The derivative of this is just c. So we would integrate between 0 and t as our given interval, the square root of a squared plus b squared plus c squared. And of course that's just the square root of a squared plus b squared plus c squared times t. So that's our function s of t. So rewrite our r from example 2, that's this function, using s as a parameter instead of t. Well, see, s equals square root of a squared plus b squared plus c squared times t. So if we substituted for t, t would be s divided by the square root of a squared plus b squared plus c squared. So once we've gotten that established, then we just take our vector valued function, and for every t we substitute s over square root of a squared plus b squared plus c squared. So now our vector valued function with s as variable is x0 plus a times what used to be t but now replaced with s, I, plus y0 plus what used to be b times t is now b times this parameter, j, plus z0 plus c times what used to be t times k. And r prime, remember if you're taking derivatives, this a divided by the square root of a squared plus b squared plus c squared is just a constant, so r prime of s is just a over this plus b over this plus c over this, sorry, a over this times I, b over this times j, c over this times k, because the z0, the y0, and the x0 are all constants. So therefore, the length of this derivative of our vector valued function with s, arc length, as its parameter is equal to 1, because if we took this and say let's find this length, it would be the square root of this squared plus this squared plus this squared. Well, that means it would be a squared over a squared plus b squared plus c squared plus b squared over a squared plus b squared plus c squared plus c squared over a squared plus b squared plus c squared. In other words, it would be a squared plus b squared plus c squared over a squared plus b squared plus c squared, which gives us 1. So now we have arc length as parameter of the curve. If we want to know the length of the curve on some interval AB, we can say, oh, by the way, on the, let me call it the S interval, AB, we can just use the arc from A to B is integral from A to B length of r prime s ds, which is just 1 ds, so it's just b minus a. It's a good reason we want to make a curve written with arc length as a parameter, because when we want to find this length, if arc length is a parameter, we just subtract the a from the b. I knew you'd think that was handy.